Hello everybody. So I got a comment on my video that most of you probably saw already on the wireless chipper controller I built. So let's talk about why I did it, how I did it, and how much I'm into it, and throw in a disclaimer of if you do this, I don't assume any responsibility for anything that happens bad to your equipment. If something happens, I did not tell you to do this. I just showed you how I did it. So why would we do this? Okay, well, number one, chippers are auto feed most of the time now. Maybe all the time, honestly. I don't know. I'm not around them enough. The PCM module burned out that controls the auto feed, and it was something like $8,000 to fix. That's not gonna fly. This was $200. So whenever that burned out, it was wired up on a double pole, double throw switch like this. So it took two people to run it. One guy feeding with the excavator, and one guy running the switch. And it's kind of not fun to do that by yourself, because if you got to jump off the excavator, run over there and hit the switch, sometimes the chipper stalls out, sometimes you fall, you have the real risk of really hurting yourself by jumping off the excavator. And you got to be so fast about it, it's not safe. So we came up with the idea. Actually, I didn't come up with the idea. My buddy did. He wanted to somehow make it wireless. And I said, well, I'll figure it out. So I did. Let's get into that. So here's kind of a parts list of what you need. You can just ignore this. You need a 30-pack or a 4-pack of 30 amp relays. Just your standard automotive aftermarket 5-pin style. 30 amp is way overkill, but part of the reason we did that is because you could just run down to AutoZone, Napa, O'Reilly's, wherever you got to go. Pick one of these bad boys up and you're good to go. I use this aluminum split case. It's just a nice box to keep everything clean. It's 2.76 by 5.71 by 5.91. That's your dimensions. Everything fits real nicely in there. You need 2 of these toggle switch covers. Well, one. They come in 2 packs. Part number is GSW20. That's right there. And then you need a Warn 39886. That's a plug to accept the little round 5-pin winch plug. You're going to need a double pole, double throw switch. This one is not the one I used, but it needs to lock in one position and be momentary in the other. When you buy the relays, I bought them on Amazon. They're like 18 bucks. Make sure you get the one that has these plugs. They all slide together, and they just really kind of tidy it up. Now this looks like a mess because it kind of is. This was my first attempt and it was failed. One other thing you don't necessarily need, but I used and it made it a lot nicer, was these little junction blocks. You can get these on Amazon too. They're cheap. But it jumps power from this screw to this screw, and then each one of these banks is individual. All this really does is give you a nice clean junction, so if you got to take something apart, it's a lot easier to do. I ran, power, ground, and then off my winch control. Tied stuff together in here. It works really nice. And then last but not least, you need a winch controller. Pick whatever you want. I use this one. It gives you an 80-foot range. You can get it at Harbor Freight. The reason I got this is because my intent was to take this apart and retrofit it into the left joystick so you can run it and not have to try and hold this and do it all. But this actually works pretty sweet because you can walk away from the chipper and grab another branch and throw it in. You can actually, because it's magnetic, hang it on one side of the chipper, and that way if you're feeding from one side, you don't have to walk around to the other side to work this switch. And then, yeah, so that's kind of where we're at with that. Now, let's see how we did this. Alright, so to understand what's happening here, you need to understand relays. So let's talk about them quick. Most of you probably already know what this is, but we're just going to touch on it because some people may not. So, start here at pin number 86. That is this guy right here. That's the one you send your trigger to. And when you trigger that, what that does is transfer power from 87A to 87. So, if you see here, I've got pin 87, power out switched, and pin 87 is power out. That's because you have power here if you put power here, and if you trigger this, it switches from this to that. And then obviously you need a ground. So that's that simple. But that's your 12 volts in, switch, there you go, you get it. So what I did here was, honestly, you could probably eliminate this. This is all hooked to the key switch on the chipper, which is 12 volts. And again, it doesn't matter, this is low amps. So anyway, you turn this on, and it sends power into this switch. And then nothing will run until you turn this switch on. So you put this in the on position. And this comes over here, sends power to number 30. You get power out at 87. And that powers the forward drum to feed the chipper. Now you want to stop it, down, you're in the middle, nothing's working. If you want reverse, you click it down, that comes over here, triggers the reverse relay. That's simple. So, here's where the remote comes into play. We'll call that on. Sorry, that doesn't lock on, so it's harder to illustrate, but so now you're on and your feed is going, and it's just sending logs in. Now it starts to bog down and you need to stop it or reverse it. So what you do is you wire your winch controller, pick whatever you want, in or out, for your winch line. You use this, you come up here and you trigger pin 87, pin 86, I'm sorry. That gives power at 87, that comes over here and triggers pin 86 on your forward relay, which takes power away from 87A, puts it on 87. You don't wire anything to that in here, and that eliminates power to the forward solenoid, stops the feed. Let off, breaks connection here, forward continues. If you want to go in reverse, you need to trigger both of these relays. So if you look here, come over, you trigger 86 on this one and 86 on this one. Now, the same function happens here. It comes over, stops that. When you trigger this one, powers 87 and turns reverse on. It's that simple. Now, this is actually the correct wiring. Just kind of ignore what that is there. You get your power and your ground, and then these are your outs for your motor. One of these had to be unhooked. I don't remember why. It was specifically one of these bottom crossover ones. It was trying to feed more than one relay for some reason. I don't understand exactly what was going on there, but that's how it worked for me. Now, as far as wiring this, you need one that has power at all of these pins. So it has in and out. Let me rephrase that. You need one that has a wire on all of these pins. So you have in and out. Now your typical is your power comes in here and it either puts 12 volts at in or 12 volts at out. That's the normal 3-pin wiring. This particular control module needs switch 12 volts, the ground, and this one's always in there. I'm not really sure why it needs these, but it does. And this is how you wire that. This is your little notch that lines it up so you get the pins correct. This here, what I did was I put a little a set screw basically in here just to hold this whole thing on so it doesn't fall off through the vibration of the chipper. And then what I did that you'll see on the video, which keep this in mind if you do it, I put an LED on the power wire out for forward and reverse. I had red here and green here. If you're going to do that, pick a robust LED. It was more of a troubleshooting light, honestly, because if something fails and you're not getting power through either of these two, the LED won't light up. So that was kind of the idea behind that. And also you can kind of look over and see if the green light's going, you know it's in forward. If it's in reverse, it should be red. Neither of those LEDs work. They just did not survive the vibration. So that's where we're at anyway. I'm gonna go in there and I'll edit up the rest of this video and splice in a couple clips from the other videos I took during the build here. Anything else that you guys want to follow up on, just leave it in the comments, and I'll do what I can do to try and help you out. If you need any revisions to this, you can leave that in the comments too, and I'll try to do my best to help you work through any revisions you would want. So anyway, that's where we're at. Okay, so this is a temporary switch. It'll lock on in that position, but green represents forward, red is reverse. So on the wireless controller, we're going to use out to stop the feed and in to reverse it